Hello, in this video we will talk about Boolean type. So to define Boolean type in Haskell, we can write this line. Data type bool equals and two value constructors, true and false. This code can be translated to Scala in the following way. So we define sealed trait bool. I recall that sealed means that all children of this trait should be placed in this file. And we define two case objects, true and false, that extend bool. Case object means that we can use this object for pattern matching. And this code can be translated to Java in the following way. We define interface bool and two classes, true and false, that implement bool. Okay, so to define Boolean type in type theory, as usually we can specify a type formation rule, constructor rule, eliminator rule, computation rules, and uniqueness principle. So type formation rule states that in every context gamma, bool is a type. I recall that context can be considered as information about types of variables. Let's say variable A has type A capital, variable B has type B capital, and so on. So bool is a type. Constructor rule states that in every context, true and false are values of type bool. Or so we can say that true and false are constructors of our type. And rule for eliminator. Eliminator from Boolean type into some type C is usual if. So we make pattern matching over Boolean value x, and if it's true, then we have C1. Otherwise, if x is false, we have C2. Okay, next rule is computation rule. It's so-called beta reduction. This rule specifies what happens if we apply first constructors firstly and then eliminator. So obviously, if true, we have first argument. If false, we have second argument. And uniqueness principle is optional, and there is no need in uniqueness principle for Boolean type. Okay, so let's look at some code, and we will use proving ground library. So we start REPL, we go to root of the project, root where we cloned repository with our library proving ground. Then we execute command sbt mantle test console. This takes a while. Let's wait. Okay, it resolves some dependencies. So Scala REPL is loaded, and now Ammonite REPL will be loaded. Okay, we can start. Okay, but if we try to use it, it fails. The thing is that Ammonite REPL works for some reason unstable with Scala 2.12.1. So one way to solve this issue is to go to build.sbt file and change version of Scala to 2.11.8, but we will not do that. We just wait a little. Okay, and now it works. So we can start. We will define, using this library, Proving Ground, we will define Boolean type as an inductive type. So we write that bool, which will be printed as Boolean, is a type. We declare variable b, which will be printed as b, as a Boolean variable. Then we write definition of Boolean type as an inductive type. It states that bool has two constructors, true and false, and we will write true as true, false as false, in order to have no confusion with built-in true and false values from Scala. Okay, let's feed these lines to REPL. Okay, the trouble is that we did not import implicits. Now let's try again. Okay, it works, and we have two constructors, true, which is printed true, and false, which is printed false. Okay, so for example, let's define a function of negation or logical not. Yeah, it's a function from bool to bool, and we make pattern matching on its argument. If it's true, then we return false. If it's false, we return true. Okay, let's check. Not true is false, and not false is true. Okay, now let's define function conjunction, yeah, or logical AND. It's a little bit more complicated. It's a binary operation. So we take two booleans and return a boolean. We take two booleans and return a boolean. So once again, we are making pattern matching on its first argument, and if it's true, then we return this lambda. If it's false, we return this lambda. Okay, it should be clear because true and b is b, and false and b is always false. Let's check. Okay, and true and let's say false is false, and for example true and true is true. Okay, so now you are ready to solve problems from practice for Boolean type. Let's say define disjunction, define logical XOR, or define a function of equality of booleans, or something like that. Okay, thank you for watching. See you next video, and good luck with practice.